this heavy, complex gear assembly has seen better days, locked up by years of dirt and rust in this outdoor salvage yard. Today, one craftsman begins the meticulous process of measuring and reverse engineering its core components. Accurate caliper readings are the foundation of any successful restoration. They dictate the exact tolerances needed before a single cut is made on the lathe. He mounts the heavy gear directly into the lathe's chuck, securing it for the high-speed work ahead. With the exterior profile shape, the focus shifts to the internal geometry. A massive, twisted drill bit plunges into the spinning center of the gear, actively boring out a deep, grooved core. This aggressive material removal is essential to clear out the compromised inner walls and prepare the bore for new threading. High-speed drilling generates tremendous friction, causing the continuous ejection of spiral metal shavings. The helical flutes of the drill bit are designed specifically for this purpose, pulling the cut material away from the cutting face to prevent heat buildup and bit failure, creating a perfectly concentric internal cavity. Requires steady pressure and a rigid setup, ensuring the new bore aligns perfectly with the gear's outer teeth. Without this precision, the final assembly would suffer from destructive wobble under load. Moving on from the internal threads, he introduces a new solid cylinder of raw steel. Using a red marker, he lays out the precise dimensional boundaries for a replacement shaft. As the cutting tool makes its first pass, it begins shaving away the outer layer, following the marked line to establish a smooth, uniform baseline. Reducing the diameter in controlled stages prevents stress fractures in the metal. The next stage involves turning down a cylindrical aluminum workpiece at high velocity. Aluminum is softer than steel, requiring a different cutting geometry to prevent the tool from tearing the metal. Fine. Parallel grooves are cut into the surface, creating a reddish-brown threaded profile that contrasts sharply with the silver base. This intricate threading will serve as a crucial locking mechanism for the surrounding assembly. As he continues to reduce the overall diameter, the chuck's powerful jaws maintain absolute concentricity. He brings the original rusted gear close to the lathe to visually verify the alignment and scale of the new work. Comparing the freshly cut threads to the old, worn components ensures the replacement part will integrate seamlessly into the original hydraulic housing. A much larger, disc-shaped component is mounted next, resembling a heavy-duty brake rotor. The cutting tool engages the cast iron face, sending sparks flying as it carves away the rough, oxidized exterior. Cast iron contains high levels of carbon, which makes it incredibly durable but also brittle if machined too aggressively. The operator takes shallow, deliberate passes to achieve a perfectly flat and highly reflective surface. To manage the intense heat generated at the cutting edge, a specialized cutting fluid is applied directly to the tool interface. This lubrication prevents thermal expansion from warping the disc during the operation. Finally, a series of precise, evenly spaced grooves are cut into the hardened face, matching the reddish-brown thread pattern established earlier. These grooves will provide critical friction and seating surfaces. Once the hydraulic assembly is under immense pressure. With the new shaft welded to the gearbase, the heavy fabrication is complete. He uses an angle grinder to clean up the dense weld bead, shooting a shower of sparks across the yard. Smoothing this transition is about more than aesthetics. It removes potential stress risers where microscopic cracks could form under heavy rotational loads. The resulting uniform surface ensures the joint is as strong as the surrounding steel. The focus now shifts to an entirely different restoration challenge. A damaged 5-spoke aluminum wheel rim. A massive, jagged section of the outer lip has been violently broken away, rendering the wheel useless and unbalanced. Instead of scrapping it, he mounts the rim into the lathe's large chuck, using a T-handle wrench to lock the jaws down tight. Securing such an awkward, asymmetrical shape requires careful attention to runout, ensuring the wheel spins as true as possible before any cutting begins. A long, threaded steel rod is clamped into the tool post to serve as a rigid guide for the upcoming operation. As the lathe powers up, the cutting tool makes contact with the inner diameter of the rim. Aluminum chips fly outward as the tool shaves away the oxidized, contaminated surface metal. Paint, road grime, and hidden microfractures cannot be welded over successfully. The filler metal requires a perfectly pristine surface to bond properly. By machining a bright, clean, circular track along the inside of the rim, he establishes a flawless foundation for the structural repair that will follow. The tool is fed deeper into the wheel well, guaranteeing absolute uniformity across the entire inner circumference. When he retracts the cutter and stops the spindle, the newly machined surface is checked by hand. It is perfectly smooth, ready to accept the heat and molten aluminum of a heavy structural weld. Moving the rim to a stationary stand, he attacks the jagged outer profile with an angle grinder. The goal here is to carve away the violently torn edges, establishing a smooth, continuous curve that matches the wheel's original geometry. Leaving fragmented metal behind would create weak points and interfere with the final balancing of the wheel. By carefully sweeping the grinding disc along the broken transition areas, he manually sculpts a clean, symmetrical contour, preparing the exact void that will soon be rebuilt. The rim is returned to the lathe for its final, crucial shaping pass. The cutting tool engages the outer lip one last time, shaving off a paper-thin layer of aluminum to blend the repaired section perfectly into the factory curve. This precision machining ensures the outer bead seat is flawlessly round, allowing a tire to hold pressure without leaking. The bright, polished surface reflects the workshop lights, hiding all evidence of the previous structural trauma. Unclamped and brought out into the daylight, the finished 5-spoke rim looks factory new. What was once a shattered piece of scrap metal has been completely reclaimed through careful cutting, grinding, and patience. Back at the lathe, a new metal ring, marked with a pattern of circular indentations, is spinning at speed. The craftsman carefully presses a blue marker against the rotating surface, drawing a perfectly straight, continuous band around its circumference. This simple painted stripe acts as a high-visibility guide for the intricate, multi-stage machining process to follow. In dimly lit workshop conditions, a bright layout line is essential for tracking tool depth. He transitions to using a specialized, fine wire-like cutting tool to face another 5-spoke rim. This highly aggressive cutting profile is designed to shear away material in long, continuous ribbons rather than tiny chips. Fine, curly metal shavings immediately begin cascading off the cutting edge, accumulating rapidly on the machine bed. The extreme rotational speed of the lathe, combined with the sharp, narrow tool face, leaves a remarkably smooth, almost mirror-like finish on the raw aluminum. Operating at this speed requires absolute rigidity in the tool post. Even a fraction of a millimeter of vibration would cause the tool to chatter and ruin the smooth surface. The constant stream of curly shavings indicates a healthy, efficient cut, rapidly bringing the face of the rim down to its final gleaming dimension. The final passes bring the face of the wheel to a perfect, brilliant polish. With the machining complete, the spinning stops, and the heavy chuck releases its grip. Carried out into the rough outdoor yard, the finished 5-spoke rim gleams against the dirt. The transformation is absolute. The precision of the lathe has completely erased the years of wear and damage, leaving behind a pristine, structurally sound component ready for the road once more. The next phase focuses on the internal hydraulics, starting with a heavy, dark metal component featuring a splined shaft. He uses both hands to guide the awkward, unbalanced weight into the chuck, making micro-adjustments with a hand tool to ensure the piece sits perfectly dead center. A secondary rod is used to verify the alignment before the massive spindle powers up. Once up to speed, the boring bar is driven deep into the hollow center. The cutting tool aggressively attacks the inner diameter, stripping away the dark, hardened exterior to reveal bright steel underneath. Boring out, An internal cavity requires immense cutting force, and the steady accumulation of shavings proves the tool is biting deep. By widening the internal diameter, he is establishing a perfectly concentric bore that will house the moving pistons of the hydraulic assembly. The precise shape of this inner wall is critical. Any imperfection or taper will allow high-pressure hydraulic fluid to bypass the seals, rendering the entire system useless. The continuous shaping process refines the interior edge, cutting complex threads and steps deep within the core. The dark metal surrenders to the high-speed steel, transformed into a highly precise mechanical housing. Moving away from the machines, the final fitting requires a different kind of precision. He applies a generous coat of gray abrasive paste to the machined surface of a metal cylinder. This cylinder is then carefully seated into a larger circular base plate that features multiple precision machined holes. The coarse lapping compound trapped between the two surfaces will act as a liquid sandpaper. By rotating the pieces against one another, he will create a perfectly mated, airtight seal that no machine tool could ever replicate perfectly. Back on the lathe, a cylindrical workpiece is subjected to a blistering, high-speed finishing pass. The cutting tool dances across the spinning surface, carving out a series of fine, concentric rings that step down the diameter. Operating at this extreme velocity generates tremendous friction, occasionally sending small blue sparks flying from the cutting interface. The sheer volume of material being removed creates a massive, tangled bird's nest of metal shavings that nearly obscures the workpiece itself. These heavy, continuous chips prove the tool is cutting at peak efficiency, avoiding the rubbing and heat buildup that ruins tempers. As the heavy shavings are cleared away, the final geometry is revealed. He unclamps the freshly machined component and presents it to the camera. The deep concentric grooves and smooth, stepped surfaces are flawlessly executed. The raw stock has been entirely reshaped into a vital, high-tolerance mechanical organ.
गरम है ठंडा गरम ताकि रहता है
The final hydraulic assembly requires heavy structural modifications. Two men coordinate at the drill press to attack a thick, circular metal component secured within a specialized multi-hole indexing fixture. While one operator plunges the heavy drill bit deep into the hardened steel, the other continuously floods the cutting zone with liquid coolant from a plastic bottle. This constant flow of lubrication prevents the drill bit from overheating and losing its hardened edge, while flushing away the massive volume of steel shavings being generated. Drilling deep, large diameter holes through solid plate steel requires immense downward pressure and patience. The multi-hole fixture ensures absolute positional accuracy, guaranteeing that every new bore aligns perfectly with the mating components. As the bit punches through, heavy chips pile up around the base, requiring constant clearing with a dark cloth and a brush to prevent the flutes from clogging. The teamwork is essential. One man manages the aggressive feed rate, while the other manages the intense heat. The drilled component is immediately transferred back to the lathe chuck for an even more aggressive boring operation. A massive, twisted drill bit is locked directly into the lathe's heavy tailstock. Instead of spinning the drill, the chuck spins the workpiece, driving the metal forcefully into the stationary bit. This setup provides unmatched rigidity for deep hole boring. As the large flutes bite into the steel center, a chaotic, swirling vortex of heavy metal shavings and liquid coolant is ejected from the bore. The tailstock hand wheel is slowly cranked forward, feeding the massive bit deeper into the hydraulic housing. This operation clears out the central cavity, requiring extreme torque from the lathe's gearbox. The thick, aggressive shavings curling off the bit demonstrate the raw mechanical power required to hollow out solid steel billets. With the internal cavities established, the focus returns to the external connecting rods. A cutting tool smoothly advances along a spinning steel rod, chasing a fine set of external threads. This delicate, high-precision pass creates the sharp, uniform peaks and valleys required for a high-strength mechanical fastener. The slow, controlled feed rate guarantees the thread pitch is flawless. Moving to the heavily splined hydraulic block, the craftsman inspects the freshly cut teeth before engaging the cutting tool once more. He begins shaping the outer perimeter of the splined gear, shaving away the rough cast iron to establish a perfectly smooth, cylindrical housing. Truing up the outer diameter ensures the block will seat perfectly. within the larger hydraulic assembly without any radial runout. The steady hum of the lathe and the continuous ribbon of steel reflect a process completely under control. The final shaping passes bring the complex splined component to its exact finished dimensions. As the cutting tool makes its last traverse across the spinning steel, a fine shower of sparks signals the precision of the high-speed finish. The external threads are refined, the bearing surfaces are polished, and the deep splines are brought into perfect concentric alignment. The raw, oxidized salvage has been completely erased. What was once a pile of broken, rusted scrap is now a complete, high-tolerance mechanical assembly. Revived, rebuilt, and heavily fortified, these internal parts are ready to bear the immense loads they were designed for. Some things are worth the long, demanding road of restoration.
हटा के हटा देना